Okay, here we go. Number one. This was a little quiz that I just gave my class, and I am now recording this so that anybody who's missed today can kind of learn from what we're doing. Number one on this little practice quiz was, how do I fix this so that I can get the fractions out of here? You multiply by x and 3. I'm going to call that 3x. And 3x here and 3x here. Final answer, once I multiply all the way across there, these guys cancel. 15 plus those guys cancel. 2x equals 9x. You with me so far? Now you subtract. You feel like I have a whooping crane in my class. Minus 2x. And now I have 7x equals, it is definitely a Friday, 15. And now final answer is 15 over 7. Now, if they made that 2 and 1/7, that's fine too. All right. Nope. It's not right. Okay. On to number 2. Number 2. You're going to multiply by x minus 1, and you're going to multiply by x plus 2 on all the parts. X plus 1 and x plus 2. And x plus 1 and x plus 2. All right. Shh. Quiet, please. That's making it difficult for me to concentrate. All right. So this will cancel this, and I have 5x plus 10. This will cancel this, and then I have minus 3x, and this is tricky. This negative gets people every time. This negative right here means it has to be distributed also. So that's going to be 3 times the 1, but it's negative 3. A lot of people will goof that part up right there. Equals. And then this last part is where it gets really complicated because I got to multiply all that out. So then I have x squared plus 3x plus 2, but then everything has to be doubled. So that will come out to 2x squared plus 6x plus 4. This is how complicated your next test is going to be. Get ready for it. All right. And now I'm going to put these guys together. That and that go together, and that's 2x. That and that together plus 7. And now to finish this deal, I have to get all my stuff onto one side. So I'm going to say 0 equals 2x squared plus 6x plus 4. And then I got to put these guys over to the other side. So I'm going to subtract 2x. And 6x minus the 2x should make 4x. And then I'm going to subtract 7. 4 minus the 7 makes negative 3. Did anybody, look on the paper please, see if anybody got that far. See if your person got that far. Raise your hand. Who got that far? Whose person? All right, only 2 people got that far. So, what does that tell you? If so far only 2 people can get close to the end, that says that it's hard. Yes? Okay, good question. If I make this the complete opposite of itself, think about this now. If I multiply both sides by negative 1, isn't that okay? So in other words, can't I make everything the exact opposite? Opposite of that, and that? Yeah, that's okay. You can change the signs to the exact opposites. Anyway, now to finish it off, I am pretty confident this thing does not factor. So then from here I would go x equals negative b, which is negative 4, plus or minus square root of b squared, which is 16, minus 4ac, all over 2a, which is 2 times negative 2 makes negative 4. And the a is negative 2. I'm loving you less right now. And c is negative 3. And now I'm going to multiply it all out and get the final answer. So 4 times 2 is 8. 8 times 3 is 24. And I got to add that to 16 because there's 3 negatives. I got to subtract. So 16 minus 24. Oh, there's a negative underneath the square root. You know what that means? No real solution. After all that, that's kind of cruel, but that can happen on the test too. If you got this far and then said no solution, yeah. But if all you do is think, I don't think this has an answer, I'm writing no solution. No, no credit. Okay. Now, do you remember I showed you that question? It was number 3 that was kind of a preview of what you had to know how to do. Let me show you how you're going to solve problems like number 3. Okay. If you have 20 milliliters of 35% acid and then you add some amount of pure acid, how much should you add so that you'll have 65% acid? All right. This is the part where you need to settle and write down a formula and put a big star by it because you need to memorize this one. This is another big formula that you need to know. Yes, get the paper back to the person. Just grade it out of 2, and some of them will have 1, and I'll be impressed actually with 1 out of 2. 2 out of 2 is impossible because nobody got the second one right. Okay. Somebody has been feeding you something that is not helping. It's working. I'm going to have to re-record it 6th hour. That's to keep that from happening. Exactly. Jeez. Okay. So this is the part where you write down a formula. I'm that close, so don't push me. On this formula, put a star. You're going to want to have it memorized. A1 times %1. That stands for amount 1, which is like how many milliliters it is. Amount 1 times %1 plus amount 2, A2, times %2. That's the other thing you're mixing with it, the other amount, and the other percentage of that amount. So let's say it's 20% acid being mixed with 70% acid. And then that will equal the tote, which of course means total amount, and the multiplied by the tote percent. And that means the percentage that the mixture is. So, for example, the one that I have up on the board here, you would use this formula like this. The amount 1 is 20 milliliters. The percent 1 is 0.35. Just put it right underneath the formula you just wrote down. Plus, the amount 2, I don't know how much I'm adding, right? So I put X. Times the percent 2. That's, it's pure acid. No, that's 65%. That's the total. That's the mixture. What's pure acid? What percent? 100%. So I'm going to put a 1.0 or 1.00 just because this other one has 2 decimal places. Get that? Pure acid's 100%. All right, and then the last is equals the total amount. The total amount I don't know still because I don't know how much I'm going to mix, but what do I write? 20, not X, 20X is close. 20 plus X, yes. Why? Because I had 20 of the one, and I'm going to add X of the other. 20 plus X times the total percent, and the total percent they gave you, they want it to be a 65% mixture when they're done. All right, so then how do you solve this from here? Well, I have 2 ways. I can either solve it with algebra, or if they allowed you a graphing calculator, what could you do? Graph both sides and sign where they cross. Okay. Now, I personally think that in a problem like this, it's easier to graph both sides and see where they cross. So why don't you grab your graphing calculator, and I would personally do a little simplifying before I put it in. I'll write down that part, and you tell me what happens when you put these into your calculator. 1.00x, of course, just means x. And this one I would probably, you know what, I'd probably just leave it like this. 20 plus x, and then times 0.65. That way I don't have to do any math in my head. I'd make this one y1. I'd make this one y2. And you got 2 equations, and you graph them, seeing where they cross. In a minute, I'll show you how you do this with algebra too, but I'm going to start with just reminding you, this is probably one of the most important things you could use on the ACT test, because on the ACT there are so many different kinds of equations they want you to solve. On a typical 60 question ACT, you're going to have about 10 equations by the time you're done if you're doing it right. A lot of the problems, they give you a word problem and you make it into an equation, and then your equations you have to solve. And you can solve them with this method. If you're good at typing this into the calculator, it can be an awesome way of answering ACT questions. All right, so I'm going to go into my y equals, clear it out because I had some old stuff in there, just like you probably do. And now I'm going to put in 20 times 0.35 plus x. So 20 times 0.35, okay, and then plus x. Plus x. That's my first equation. My second equation. Parentheses. Question? I heard a Mr. Server. Do you have a question? Maybe not. Plus x and the parentheses, and then I times by 0.65 times 0.65. Enter. Now when I hit graph, I'm going to hope that I can see the two lines crossing. They're really close to each other, so it's really hard to see them cross. I'm going to go zoom 6 and get a more normal zoom here. See if I can see them easier. Oh, a lot different. Okay, wait a minute. Now it's way up high, so I'm going to go make my window bigger, basically. I'm going to just zoom out. Remember, when you hit zoom out, it won't actually zoom out until you hit enter again. So there, I zoomed out. Are they crossing yet? Hey, they're crossing. Okay. If they aren't crossing yet, get it so they are. Then you go second, calculate intersection point, number 5. You go enter, 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 and there it tells me where they cross, 17.14. You get how you'd probably would have needed to use the calculator anyways at some point? Because if you're going to have some decimal at the end like 17.14, it probably didn't come from you multiplying simple numbers. Okay, so the point is, if you're going to have to use the calculator anyway, might as well just start early in the equation, graph both sides, see where they cross. And I know it's true, the algebra on this isn't that hard. You could probably do it with algebra too, but this way we can let you graph anything. So when, like, next unit, we're doing things like this, sine theta equals -1/2. I don't know how to solve that, but I do. How? Graph both sides, see where they cross. It works. I'll show you what sine looks like. Sine looks like this. And then -1/2. Where is y equal to -1/2? It's a line that runs right like this. And then you might notice, wait a minute, there's a whole bunch of answers, Mr. Server, and that's a good thing to notice. Yes, there are. There's actually unlimited answers. So usually on a problem like this, we say we want the answers that are between 0 and 2 pi. You're going to learn all of this later, but my point is, you don't even know how to solve this thing, and yet you could solve it by just graphing both sides, see where they cross. It's a powerful method. All right, so back here. I was in the middle of this problem. I got into here, and we got like 17 point whatever. What if me and old Mr. Server said you had to solve it without graphing? Well, you just do some math at the calculator. What's that? Can you do that in your head? I can. 2 times 0.35. Double 0.35 doesn't sound like doubling 35, which would be like 70. Is it actually 70 though? Be 7. 7 plus x equals. Now I'm going to multiply this part out. Doubling 65, that'd be 121.30. Is it actually 130 though? It'd be 13 plus 0.65x. There, I did some of that in my head, but you could have used a calculator. And then you're going to subtract 0.65x from both sides. And then those two cancel. And then I have 1 minus 0.65 is 0.35x, and this is 7, and equals 13. And now what? Subtract 7. 0.35x equals 6. And then I take x equals 6 divided by 0.35. Would somebody take 6 divided by 0.35, please? How did I get the 7? The 7 came from 0.35 times 20.
Yeah, but how'd you know that?
Okay, I knew that that if you take the decimals out of it, I'm really going to have to do 35 times 2. Would you agree with that?
Oh, yeah.
And 35 times 2 is 70. So I knew that it had a 7 in it. And then I just used logic, and I figured out if it's 35% of 70, it's got to be something around a little less than half of 70, so what 7 number would that be? And it's 7. So again, I know that was kind of math teachery, but you could use your calculator and go 20 times 0.35, and it would be 7. All right, so at the end, what was it? 17 point something, I hope? All right, it's the same answer we got off the graph, 17 point what? 4 something? All right, good enough. 1-4? Okay. All right, there we go. So either way works. Point is, can you use that formula? Let's try another one. Totally new problem, same formula. Calc's allowed. All right, so now, yes, calcs will be allowed in this kind of a problem on the test. I just don't know yet whether or not we're going to require that you not use a graph, which would mean you'd have to show all your work the other way, but you'll have a calculator, I know that much. Okay, so would you right now consider the situation of you've got a glass of half water and half Coke. Doesn't that sound really tasty? Totally watered down Coke, okay? And the glass is an 8-ounce glass, and it's therefore 50% Coke. Instead of acid, I'm just calling it Coke. Coke is actually kind of acidic. So acidic, in fact, that if you leave a tooth in a glass of Coke, all it takes is like overnight, and the tooth is almost completely gone, just from dissolving from the acid. And there's the same kind of teeth that are in your head, like a live, healthy tooth dropped in that will disintegrate. What does that say about just splashing your teeth with pop every now and then? So it really isn't good for them, because if you leave it on there long enough, it would rot it away. Okay, so anyway, you get this half water, half pop. Let's say that you wanted to make that pop drinkable again. Would you agree that pop, if you put in a few ice cubes and the ice cubes melt in there, it actually becomes a little bit watered down? So most people consider pop a little bit watered down to still be okay, because they still allow people to put ice in their pop, right? So I would say that it'd still be okay if it was 90% pop, maybe even 95. 95% pop is considered okay. In other words, it'll now be strong enough to drink and it wouldn't even bother you. So my question is, if you had this 8 ounces of 50% pop and you need to get it up to 95% pop and then it'll taste good again, how much pure pop are you going to have to put in to make it get up to 95% pop? Started off with 8 ounces of the half and half pop. You're going to add some unknown amount of pure pop, and you're going to get a mixture that is also an unknown amount of mixture, but it's 8 plus X, and that mixture has to be 95% pop, and then it'll taste good again. Yes, calcs are allowed. All right, for those that are struggling to start, it's amount 1% 1 plus amount 2% 2 equals tote amount and tote percent. And I know all those numbers. And if I don't know one, I'm just going to put an X. The amount originally was 8 ounces of 50% pop plus I don't know how much of 100% pop equals the total amount. I don't know, but I know what it's made up of. It's 8 plus the unknown thing. And the total percent I wanted, 95% pop, will taste good again. So there's how you set it up. Raise your hand if you set it up right. All right, if you didn't, I hope you see how it's supposed to have been done. Now you have two choices. You can take the high road or you can take the low road. And in this case, honestly, I think it's just smart to use your technology. But it might actually be easier to solve it with algebra, so do it whichever way you want. There's no smarter way to me. It's whatever's easier for you. But I'm hoping things like this you can do in your head. What's 8 times a half? 4. Plus, what's that simplify to? 4 plus x equals, and now there it's getting a little dicey. I'm going to have to use the calculator anyway. So for me, I might graph y equals 4 plus x on one side. And I might graph y equals all that on the other side. I'm going to pause for a second while I do that. Okay, I'm recording again, and I'm going to hit graph. And I see where the two lines, oh, they just like, maybe you don't quite cross yet, so I'm going to have to zoom out again. I'm going to go zoom. But probably the fastest way is to zoom out. Zoom out, and then I hit enter. And now it's really tough to see where they cross, but you know what? It doesn't matter. I don't have to see it like an eagle sees a mouse on the floor of the valley. I just need to know it's on this screen. So I'm going to go second, calculate, intersect, 5, enter, enter, enter. And boom, it jumps right to it. There's the mouse, 72. Raise your hand if you had 72. Awesome. Okay.
Would that be 70%?
Good question. It's X. Look back in the problem. Where were we using X for an amount? So 72 ounces. That's a lot of pop before that thing's going to be back to drinkable. All right. 72, let me think. That's a typical 12-ounce can of pop. So how many 12-ounce cans? It would take 6 12-ounce cans of pop poured in there with it, because 6 times 12 is 72. Yeah, that works. So 6 12-ounce cans of pop poured into that mixture, then all of a sudden it's drinkable again. Takes a while. All right. And I don't know how, I'm curious, somebody out there probably knows exactly what percent you can water down pop before it starts to taste bad to most people. But again, most people like having, or are okay with having lots of ice in your pop. There are people that will say no ice. You've heard that, right? All right. Okay. Yeah, that's true. If you don't get free refills, then yeah, you don't want to like use up half of the pop area by putting ice in there. So, okay, so your homework for today is just like that, and let's actually get those out to you right now. Here comes your worksheet. I'm going to do one with you, so I'm going to keep the recording going. I'll pause for just a second while I hand these out. Okay, so here we go on number 1. What am I going to multiply by? Well, I can't multiply by just x plus 4. I can't multiply by just x minus 1. But I'm going to multiply by both. Some of you are talking too much in the back corner. Thank you for stopping. All right. See, she's just trying to learn, and you're distracting her. 4x over x plus 4. And then plus 3 over x minus 1. And it's equal to 15 over... Now, this thing looks like it's really nasty at the end, but it's all just going to cancel anyway. The x squared plus, because when you multiply out the x plus 4 and the x minus 1, it's all going to work out nice. All right. So here's an x plus 4, and here's a x minus 1. I'm doing it on each side of it, and that's just because it makes it easier. It's hard to have enough room to do it the other way. And then over here, x plus 4, x minus 1. You might want to do it that way too. It's up to you. But my advice to you has been, if you ever see a part in the problem that looks like it could be factored, like maybe that part, factor it. And then you won't really need to, because in this case, it'll just factor to x plus 4 and x minus 1, just like you'd expect. All right. Then, a lot of stuff cancels. Cancel, cancel. It's like a canceling festival. Cancel, cancel. Cancel, cancel, cancel. It's the best kind of festival, let me tell you. 4x squared minus 4x plus 3x plus 12 equals 15. And from there, it should be child's play. Isn't that cool how we're getting to problems where you look at it and say, oh, that's easy, because now I just have to put it in the quadratic formula. And yet, that would have been the problem that you could, no way you could have solved that at the beginning of last year even. So, you've come a long way, baby. Moving on, let's move to, let's see, number 7 has a different kind of problem. It's a picture, and a picture's worth 1,000 words, they say. A math teacher knows what to look for in this kind of a picture. There's only one spot on that whole picture that really matters. Do you know where it is? Burn it with your laser eye beams. Laser beams. Are you burning that spot right there? Good, then you were in the right, looking at the right spot. That is the answer. That's the root. If there was a spot where both lines crossed, I'd also think that was probably the answer. Because remember, graph both sides, see where they cross. Is kind of a good way to solve things. But if they aren't crossing, then you look for the x-intercepts. All right, that's also known as the roots, also known as the zeros. And then you just try to figure out which of those answers up above matches up with that. And then the other answer must be extraneous. All right, moving on to 9, 10, and 11. Number 9 is that one with the mixture. I hope you've got that thing memorized by now. It's not that hard. Amount 1% 1 plus amount 1% 2 equals total times the total. Total amount and total percent. And now I'm going to stick these numbers for number 9 in there. It says how many, ooh, it leads with the question word. How many milliliters, that means I don't know how much is the first amount. So what do I put if I don't know how much it is? X. X times the percent for that is pure acid. What do I put for that? 100%, otherwise known as 1.00. Plus the other amount is 100 milliliters of 30%, no, 35.35. And that equals, and this last part is where a lot of the mistakes are made, so be careful at the end. X, what would you think? X plus 100, because these are the two amounts, an unknown amount and 100. So the total is X plus 100. And then the total percent, they'll just tell you. What is that? In this case. Thank you, 0.75. Now, from here, your choice. I personally had cleaned it up a little bit before I tried to type it in the calculator because it saved me a lot of time. 1.00 times X is just X. And 100 times 0.35, if you can't do that, come on, we shouldn't be up in precalc. Multiply that, move the decimal over 2 spots, 35. And then this other one, I guess I could do that too, 0.75X. And then the last part is 0.75 times 100, which would be 75, yes. And now I might graph both sides and see where they cross. Or if I'm just feeling like, you know, I'm just going to solve it the normal way. Subtract 0.75x. 0.75x. These cancel. And then I have to do, what is that? Well, it's 1x minus 0.75x. It's like $1 minus 75 cents. 0.25x plus 35. And from there, I would subtract 35 and divide by 0.25. But if you were graphing this whole time, you'd probably already be done. So your choice, you pick. Okay, I will trust as soon as a couple kids get the same answer. What did you think the answer was? They got it? It is. So I did 0.75 times x, which makes 0.75x, and 0.75 times 100, which makes 75. If you got an answer, even if you're not sure, just once you tell me, I'll pause for a second while we get some answers. Okay, so it seems like the answer the kids are coming up with is x equals 160. I can finish this. It's not that hard. I'm just going to subtract 35. 0.25x is equal to 40. And then I have to divide 40 divided by 0.25. And if you think about that, x equals 40 divided by 0.25. You know what 0.25 is really? It's 1/4. You know what divided by 1/4 means? Divided by 1/4 means multiply by 4. And so 40 times 4, 160. Yep, I can verify 160 is it. The only problem with the graph both sides and see where it crosses thing is just that the window sometimes has to be enlarged to be able to get it big enough to see where they cross. That's the only pain in the butt part about that. I really wish you could set the default on your calculator to be like always graphing to like x is 100 and y is 100 because, and you can just go in the window and change it, but then if you ever clear your calculator, it just goes back to 10 and 10. But, all right. We've done a couple off your worksheet. The rest of them are yours. Hate to take away all your fun, so the rest is yours for homework.